Hello again. What we're going to do is dig deeper into slope and start seeing some stuff that goes on in terms of vertical, horizontal lines, parallel lines, and perpendicular lines. Just in regard to slope, we're just going to scratch the surface here, and I'm not going to go crazy with questions about parallel and perpendicular, but just enough to get you prepared for what's coming in the future when it comes to parallel and perpendicular. So what we're going to do is describe the slope of the line that's passing through each set of ordered pairs here, and then we're going to identify the slope perpendicular to it. So we'll dig into that a little bit. And so we're just going to go over three pairs of ordered pairs. And the first pair, we've got two ordered pairs, and as we know from the previous lesson or previous lessons, that when you're dealing with ordered pairs, the slope is simply the change in the dependent variable over the change in the independent variable, or as we better know, the change in y over the change in x, or as some of you might also have learned at some point in time, y2 minus y1 over x2 minus x1. And it doesn't matter which way you look at it, which way you conceive it. Just the way I look at it, it's the change in y over the change in x. So basically, if you have two ordered pairs, you've got two x coordinates and two y coordinates, and in order to find the change in the coordinates, you have to subtract, right? So the way I conceive of it, I'm dealing with slope as the change in y over the change in x. Okay, so all this stuff is slope. So slope is the change in y over the change in x, or what you know from the slope formula, y2 minus y1 over x2 minus x1. That's just too many syllables for me to remember, so I stick with change in y over the change in x. Anyway, let's get into to finding the slope. So we're going to have the change in y, which it doesn't matter which you're going to subtract, the blue one from the red one or the red one from the blue one. Just stick with the same order. So I'll do the blue one first. So I'll have 3 minus negative 6. And if I'm subtracting the first one first, I do the same thing with the x value. Okay, so the change in y over the change in x. So we'll do 5 minus negative 2. And it just doesn't matter which way is which. Okay, so again, I'm approaching this as the change in y over the change in x. So we have our work set out, and the rest is just, crunch some numbers. 3 minus negative 6, no matter how you view it, is always going to be positive 9. And 5 minus negative 2 is always going to be 7. So basically your slope is 9 over 7, or your rate of change of the dependent variable over the independent variable is 9 to 7. But I talked about describing the slope of each line. So how would we describe this? And another way of visualizing slope is to think slope happens to be rise over run. And if we're looking at rise over run, and this is being a positive slope, right? So we know that this is a positive slope. We know that it's going up in some manner. Okay, so that is definitely a positive slope. And so it's going up in some manner. So the rise over run, we could say it's going up 9 and going to the right 7. And we can also say that it's going down 9 and to the left 7. And that's how we can describe slopes. We can see what's happening to the line. It's either going up 9 and right 7 or down 9 and left 7. Either way, it's a positive slope. Okay, so when you're looking to describe it, it doesn't matter. Either way, it's positive. And so that's how we can describe it. And now, what we can start doing then is looking at that term, identifying the slope perpendicular to it. Okay, so now what we're going to do is identify a slope that's perpendicular to this slope. Okay, so we have to remember a couple of notes. You have parallel lines and perpendicular lines, right? So we have parallel lines and perpendicular lines. We've got to know a couple things about them in regards to slope. And the reason why this is important is for geometry reasons and horizon reasons and all sorts of neat stuff with navigation, so on and so forth. But it's just fun. Anyway, parallel lines are two lines that will never touch, they'll never cross. And as you know from previous lessons, in regards to slope, slope is the same. Okay, so if one line has a slope of 9 over 7, any line parallel to it will have the same slope. Perpendicular lines, on the other hand, intersect at right angles. Okay, so they intersect at a right angle, and that's extremely important. They intersect at 90-degree angles. Okay, that's what makes a line perpendicular. So it's not just that they cross at 90 degrees. I mean, it's a hugely specific type of crossing. So make sure you know your vocabulary. Perpendicular lines cross at 90-degree angles. So what does it have to do with slope? So parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. Opposite reciprocal slopes. Okay, so that's how perpendicular lines operate. Then I know what you're thinking. What is opposite reciprocal? It's too much vocabulary and too many syllables, quite honestly. What is opposite reciprocal all about? Seriously? Flip it and change the sign. That's basically it. Flip it, change the sign. Right? That's what you can do. I normally hate giving you things like that. It's just sloppy vocabulary and childish, but what does opposite reciprocal mean? Flip it, change the sign. So in the example A, if the slope that we found was 9 over 7, okay, so we'll rewrite that. The slope that we found was 9 over 7. Well, then a perpendicular slope would then be opposite reciprocal. Flip it, change the sign. Ta-da! So here's our answer, right? Up 9, right 7, and then that's describing the slope, and then perpendicular to it is negative 7 over 9. That's the basics of slope, right? So and scratching the surface of parallel and perpendicular, and we'll get more into it later. But just for now, the basics of parallel and perpendicular again. And that's how that works. So let's see what happens in another example. So we have example B. And what's cool about example B is that if you know what you're doing, you can just look at the two-ordered pairs and have all the information. I mean, the two-ordered pairs give you all the information right there. But you got to know what you're looking for. You got to know what you're looking at. And if you don't know what you're looking for and looking at, well, then get to work. And keep working until you know what you're doing. Because there is a way to just look at these two-ordered pairs and know everything about the question that's being asked. So we got two-ordered pairs. We're going to find the slope. I'm going to look at it the same way. And I'll do the same thing as we did before. The first ordered pair will be in blue. The next ordered pair will be in red. And we'll just look at the change in y over the change in x. This time I'll do the red one first to show you that it really doesn't matter. So negative 7 minus 2. Negative 7 minus negative 7. That was close. So negative 7 minus negative 7 over negative 5 minus 2. There's the 2. So it doesn't matter which way you're looking at it. Something's going to happen. So now we start crunching numbers. At the top, negative 7 minus negative 7. Anything minus itself, well, that happens to be 0. And then negative 5 minus 2 is irrelevant. But it's negative 7. And so you might be thinking, negative slope? Right? That's what negative 7. Is that a negative slope? And negative slope goes down like that. Is that what's going on? And no, that's not going on. And remember, always simplify your slope. If you can divide, do it, right? If you can divide evenly, divide it, right? So if it can divide evenly, do it. So what is 0 divided by negative 7? When in doubt, punch in a calculator. Seriously. use a calculator, and then watch for the e. So when in doubt, use your calculator and watch for the e. Punch in 0 divided by -7, you're going to get 0 with an e somewhere, right? An error, undefined, something's wrong. For 0 divided by -7, what's wrong with me? 0 divided by -7, you get good old 0. There will be no e. Okay, so you get 0, no e. That means 0 divided by -7 is equal to 0. So what's the slope of this line? 0. That means there's no rise, right? Look at that, no rise. And a line that has no rise looks like this. You know, a line that has no rise looks like this. What kind of line is that? That is a horizontal line. Okay, so if it's a slope of 0, we got a horizontal line, right? So the slope is 0, a horizontal line. Now remember I told you can actually look at the ordered pairs and tell that. So guess what? If I look at the two ordered pairs, you know what they got in common? The ordered pairs have a y in common. And if the ordered pairs have a y in common, that's an interesting phenomenon. That means we can actually tell the equation as well, right? If the ordered pairs have a y in common, that means the equation is y equals, okay? And it's whatever that y is. In this case, it's going to be -7. So the equation is y is -7. That's not, I'm not asking about that. I'm just saying you got to learn everything about horizontal lines. We'll get more into that. Anyway, so the slope of these two ordered pairs is 0 over 7, which is 0. So the slope is 0. Now, what's interesting? What's perpendicular to a slope of 0? So the perpendicular slope then is perpendicular horizontal. Guess what's perpendicular to horizontal? Vertical, right? So perpendicular to horizontal is vertical. How cool is that? It's just simple vocab, right? So a perpendicular slope is a slope that's vertical, but then what is the slope of a vertical line? Well, let's look at the slope we had found. What would then be the opposite reciprocal of 0 over -7? It would then become 7 over 0, right? And remember, when in doubt, use a calculator, watch for e, right? If you put 7 divided by 0 in your calculator, you're going to get 0 this time with the e. And that's going to be undefined. Error. It means the slope doesn't even exist. There is no slope. It's undefined. So the perpendicular slope to 0 is undefined. Believe it, because it's crazy. So the perpendicular slope is undefined. So vertical lines have an undefined slope. So the two ordered pairs from the question have a slope of 0, a horizontal line. That's what it looks like. Describe it. Looks like that. Perpendicular horizontal is vertical. Guess what? Undefined. That's how that works. Let's test your knowledge. So let's take a look at the third ordered pair. And again, if you know what you're looking for, you already know the answer. If you don't know what you're looking for, do your homework and you will find, hey, I'm actually learning some things by doing my homework. Funny how that works. So now we have that third set of ordered pairs, 6, 0 and 6, 5. And if you don't know what you're doing, you should already be done. If you don't know what you're doing, we'll do the same thing we've done before. So you have your two ordered pairs. We're going to find the slope as the change in y over the change in x. And it really doesn't matter which way we do it. Let's say we do the first one. So 0 minus 5. And then over 6 minus 6. Crunch your numbers. 0 minus 5 is -5. 6 minus 6 is 0. Punch that in your calculator. Guess what you have? If you punch it in your calculator, you're going to get error. So the slope is actually undefined. So the slope is undefined. What does that mean? That means there's no run, right? There's only a rise. There's no run. It's not going from side to side. So it means the line looks like this. There is no run. And that is a vertical line. That's what it looks like. So the slope of those two ordered pairs is undefined. It's a vertical line. That's what it looks like. But what about what's perpendicular to it? So now we got to figure out, well, what's perpendicular to that? Perpendicular to vertical happens to be horizontal, right? So what's perpendicular to vertical? Horizontal. And what's the slope of any horizontal line? Well, 0, isn't it? Isn't that what we just discovered in the previous example? So perpendicular to vertical is horizontal. What's the slope of a horizontal line? Perpendicular to -5/0, flip it, change the sign, is then 0/5, which is 0. That means the perpendicular slope then is 0. And by the way, could you tell me the equation of this line if I asked you? Yes, you could. Because look, we got the x-coordinates in common. If the x-coordinates in common, it's going to be vertical. How cool is that? So we have the x-coordinates in common. They both are 6. X equals 6, vertical line. Slope is undefined. So all that ties in. And that's where we start scratching the surface of parallel, perpendicular, horizontal, and in vertical. Okay, and that's it for this lesson. So we'll remind the question again. We were just simply describing the slope of the line that passed through the ordered pairs, and then identifying slopes perpendicular to it. Okay, so just some basic stuff. We'll get more into it later. Thank you much.